Good morning, student. I hope all of you are good. Now let's learn our chapter number 4, atomic structure. As we finish the Dalton atomic theory, all the features of the Dalton atomic theory you need to remember, very important for exam point of view. So what Dalton told that the atom are indivisible, but afterward some latest research, here the note is given, so the latest research work about the atom has proved that the most of the feature of the Dalton atomic theory are incorrect. Most of the feature, which means that what Dalton told, that matter or smallest particle is indivisible, atom is indivisible, and matter atom does combine, so a smallest unit of the matter, so that whatever the feature he told here, as we learned in previous year, that incorrect. But only one thing he told that is a correct, that is the Dalton was right that atom can take part in chemical reaction. So atom only taking part in chemical reaction, that is the correct one right now also. So let's learn about the what are the subatomic particles which are divided, atom further divided into the subatomic particles, which is called a fundamental particles. So the subatomic particle or fundamental particle, so let's start the study and the discovery in the late 19, which means that in late 19 discovery of the electron, proton and neutron, it is so that the atom are indivisible. So early 20th century show that the atom are indivisible. So they are composed of the still smaller particle. Okay. So the three main particle present in the atom are electron, proton and neutron. So after the study discovery of the electron, proton and neutron in late 19 or earlier of the 20th century, it is discovered that the electron and proton and neutron are present in the particle. So which are the subparticles of the atom. So that particle are known as a fundamental particle or a subatomic particle of the atom. Okay. So the existence of the subatomic particle, was proved by the fact that an atom is electrically neutral, but it can be made to gain a positive or negative charge. This means that the atom must contain tiny particle. What is the meaning of that? Here the meaning of that, the subatomic particle have a particular type of charge. Maybe they have a positive charge or they have a negative charge, and due to the positive and negative charge, they are the atom is consist as a neutral atom. The atom is consist as a neutral atom. It is a neutral. Why? Because the whatever the subparticle present in the atom, they are consist the positive and negative charge. So it is proved by the fact that atom is electrically neutral, but it can made to gain positive or negative charge. So we can made the positive charge atom, we can made the negative charge atom by gaining, or by we can gain it. Okay, we can gain the positive and negative charge. So this means that the atom must contain tiny particle, and each carries either a positive or negative charge, which means that a something present, the subatomic particle, which are a proton, electron and a neutron, these are the subparticle or fundamental particle are carrying a positive or negative charge. Some of the particle are carrying positive charge and some of the particle are carrying negative charge, and due to that atom is electrically neutral. I hope you understand this point. So this opposite charge balance each other under ordinary condition to make atom electrically neutral. Okay, so that is here given. I hope you understand till here. So this is the big this theory is given at the beginning of the 20th century, when the electron, proton and neutron was discovered. At that time they don't know about the electron, they don't know about the neutron and proton, how they are arranged in atom and how they are behaving in atom. What is the characteristic, what are the properties of the proton, electron and neutron, what are the charge they are carrying, how they are forming a positive, how they are forming a negative, all of these things they don't know, but something they know about that they can gain positive or negative charge. They have a particular positive or negative charge in its in its atom, and that's why the atom is electrically neutral. That much they know. So now let's learn all the fundamental particle individually. How they discovered, what are the properties, how they behave in an atom. Everything we will learn in this chapter. Okay. So let's start that. So the first point of this chapter is discovery of the electron. How the electron discovered. So the electron was discovered by J.J. Thomson. Electron was discovered by the J.J. Thomson, but how he discovered, what the characteristic of the electron have, that all the things we will learn. So the electron was discovered in 1897 by J.J. Thomson. Underline this. J.J. Thomson, who discovered electron, were discovered in 1897 by the J.J. Thomson, when he was studying the property of cathode rays. Cathode rays. Now what is the cathode rays? So cathode rays was discovered by the William Crookes in earlier, which means that before the discovery of the electron, the William Crookes, before the 1897, one of the scientists, William Crookes, doing some research on discharge tube. So what research he is doing? So here I am explaining through this. So this is called a discharge tube. Here this is a discharge tube. This side is a negative side, which is called cathode. This side is positive side, and which is called anode. Cathode and anode is attached with the battery, or we can say conduction or coil. Through that the heat is generated in this tube. And here in this tube there is a particular type of gas is filled, or we can say inert gas. Inert gas filled in it. Inert gas like argon, neon, xenon, helium, all of these are inert gases. So one of the inert gas he filled in this discharge tube. This is the discharge tube. So he is doing, William Crookes doing some research on this discharge tube, and what he done that he put the inert gas in this discharge tube, maintain the pressure in this tube, around 0.01 millimeter of mercury. That is a unit of pressure. 0 mm of mercury, that is a unit. Just like we are writing kilogram, gram, meter, centimeter, that type of that is same way the pressure unit, mercury of mm of mercury. So the pressure will be pressure was a 0.01 mm. Okay, and that pressure is maintained through this vacuum pump. Here there is a vacuum pump attached. Through this, thus pressure is maintained in this tube, and the very high amount of the electric current pass through this inductive coil. Very high amount of electric current pass through this inductive coil in this. So what he observed, after the passing of the high amount of the electric current in this tube, here this tube is glow. So this research he is doing. Which one? Crookes, William Crookes doing this research. So he observed that the one type of rays is passing through this cathode to anode, and that is why this bulb is this tube is glow. So that is, the rays is passing through the cathode to anode. So it is coming from the cathode. That's why that rays are known as a cathode rays. I hope you understand what is the meaning of cathode rays. So this is the discharge tube. In discharge tube, inert gas fill and the pressure how to be maintained 0.01 mm of mercury and through this vacuum pump, and the high amount of the electric current passed through this tube, and the one type of rays is passing through the cathode to anode, and this tube is glowing. And that he observed that the something is passing from the cathode to anode, that's why he told that rays cathode rays. So William Crookes doing this research on this discharge tube and he developed the cathode rays. So J.J. Thomson, he used this cathode rays. J.J. Thomson is used this discharge tube and cathode rays. So that is given here when he was studying the property of the cathode rays. So William Crookes, another British scientist, has performed an experiment to study the phenomena of electric discharge through gases. He observed that here it is not mentioned gases, but it is inert gas, which means that they are not reacting with anyone. You heard about the inert element, inert gases, helium, neon, argon, krypton, you heard about that. So that gases. So he observed that an electric current at high voltage was passed through a discharge tube. A glass tube sealed both the sides. Discharge tube, this is the discharge tube as I shown in figure. So this is the discharge tube and here this is the metal plate which are both the side. Behave as a cathode and anode, positive terminal and negative terminal. Contain a gas at very low pressure. A contained gas, here the air gas is contained and very low pressure as I explained you before, was emitted from the negative terminal called cathode. Okay, this is the negative terminal which is called as a cathode. So he called this rays cathode rays, as I told. Now, this is the way cathode ray he discovered. Now J.J. Thomson have done this. J.J. Thomson used this cathode rays and find out the characteristic of the cathode rays. So during the research of this cathode ray discovery, he discovered that something is given. So what he discovered? So J.J. Thomson studied the characteristic and the constituent of the cathode ray and conclude, which means that he was doing study on a cathode ray. And after the studying cathode ray, he conclude that a cathode rays consist a negatively charged particle called electron, present in atom, in all the elements atom. What he conclude? He doing some research on cathode rays, and after the doing research he conclude that the whatever this cathode ray it consists a negatively charged particle, and that's why it is he called is electron. Now how he conclude that here through this, what he has done, he has put this discharge tube, full discharge tube in the electric field. As we know that the electric field have a positive and negative. You have seen in a battery cell, there one side is positive and one side negative. The same thing, the electric field, if we want to put then one side positive terminal and one side negative terminal, or we can say poles. Okay, so negative pole and positive poles he put here like this. This is the negative pole and this is the positive pole. He put in this, and then after some time he transfer the electric current. He observed that the rays which are going from cathode to anode, which are deflected towards the positive pole side, like this. So which means that as we learn that the positive is attract negative, negative is attract positive. So that is a natural phenomena. So he told that if this rays have a particular characteristic, that's why it is attract towards the positive direction. So he told that this is the negative side. This is the negative charge particle present in this rays. So due this he conclude that this cathode rays consist negatively charged, and they charge these particles are have a particular mass even, and that he told electron. Okay, so that is way he found the electron. So what he told here, that an electric field was applied in a path of the cathode ray in a discharge tube. It was observed that a cathode ray were deflected towards the positive plate of the electric field, and this show that the cathode ray were negatively charged. Okay, so when the magnetic field was applied, same way he applied magnetic field, which means that a south pole and north pole. Instead of this positive and negative, he just done the south pole and north pole. So what he done, the magnetic field was applied in the path of the cathode ray. They were again deflected in the direction in which the moving negative charge would be deflected. The same way it is also deflected, like in a electric field. So this proved that the cathode ray contain a negatively charged particle called electron. So this is the way he explained a negatively charged particle is a electron which is present in this cathode ray. So by this experiment he has done this. Okay, if you find any difficulty, you ask me after watching this.